All right, so we're looking at the average rate of change, and specifically we're looking at the average rate of change in word problems. So we're going to pick up with number 2. Alcohol is metabolized by the body through enzymes in the liver in such a way that the blood alcohol content decreases linearly. It just means that it's decreasing in a line instead of some sort of curve. A study by the National Institute on Alcohol Abuse and Alcoholism showed that for a group of fasting males who consumed 4 drinks rapidly, the blood alcohol content rose to a maximum of 0.08 grams per 100 milliliters about an hour after the drinks were consumed. 3 hours later, the blood alcohol content had decreased to 0.04 grams per milliliter. Find the rate of change, the average rate of change in BAC blood alcohol content from hour 1 to hour 3. So we have hour 1 and we have 0.08 as the level, and then at hour 3 we have 0.04. So if we're looking at graphing this, that time is usually our independent variable. So that would be on the horizontal axis or the x-axis. And then these blood alcohol contents would be our dependent variable. That's the thing that we're going to measure. And so that'll be on the horizontal or the y-axis. Okay, so if I sketch that out, this is the blood alcohol content and this is the time in hours. So our average rate of change here, okay, is going to be, so we'll take this 0.04 at hour 3, so 0.04 at hour 3 minus, and then at hour 1 we had 0.08. Okay, so that's how that looks. And if we subtract that, I get negative 0.04 over 2, which gives me negative 0.02. So if I was going to give an interpretation of that in context, I would say that the blood alcohol content decreases 0.02 grams per 100 milliliter. So that's using those units there each hour. Okay, so that would be an interpretation. Go ahead and do number 3 and give me an interpretation of that. So I'd like you to go ahead and pause the video and see what you get, and then we'll come back and work it together. All right, so hopefully you gave that a try. Charlie picks apples in the orchard. By 9 a.m., he has picked 150 apples, and by 11 a.m., he has picked 550 apples. Find the average rate of change in the number of apples he's picked between 9 and 11 a.m. So our average rate of change, so again, that time, at that 9 and 11 a.m., that's going to be our independent variable. So that would go on this horizontal axis. And then our vertical axis, our dependent variable, is going to be the number of apples picked. Okay, so we'll do, let's see, at 11 a.m., he's picked 550 apples. So I'll do 550 and 11. And then the matching pair that goes with that is that at 9 a.m., he's picked 150 apples. Okay, so this gives me 400 divided by 2. So my average rate of change is 200. And that would be 200 apples per hour. We were looking to put units on there. And so that statement then would be Charlie picks 200 apples per hour. So that statement would be the interpretation of that average rate of change or that slope. And then just one thing to note, if you had decided to reverse these, so let's say you did the 9 a.m. time slot first, you would have 150 over that 9, and then you would subtract the 550 and the 11. Okay, so you've just flipped those over. And you would get negative 400 over negative 2, which still gives you a positive 200. So it doesn't matter which order you subtract them in as long as those 2 points go together. So that time and the number of apples are stacked on top of each other. So whether they're first or second in that subtraction doesn't matter. You'll still get the same result.